So good afternoon, everyone. My name is Mike Zink. I'm a professor at the University of Massachusetts Amherst, and welcome you to the GIMI tutorial. We're a very small group. I would like the people who are a little bit in the background maybe to come a little bit more up front, so we can all, sit a little bit closer together and help each other out, or maybe we don't have to walk too long distances. I promise we don't bite. We're very nice people. I have Peter, Ishwar, Kong, and Divya. Divya is going to help me run the tutorial a little bit. With me here, they can help you with any questions, and I'm definitely around to help you with any questions you have during the tutorial. And so, since we're a small group, it would be nice to keep that a little bit interactive. If you have any questions, let's just post them in the group, so others can benefit maybe from the things you're trying to understand. Might be a lot of similar questions coming up here. So what I want to do today is keep that in a way that we can, have you do, keep that very active and have you do most of the steps yourself, so you learn about how you use instrumentation with our tools, how you can run experiments on Genie test beds. And I just want to give you 5 minutes. Have you all been at the instrumentation session yesterday? Who has not been at the instrumentation session yesterday? Okay, so let me just do just for you. Just a very quick run through. It's going to be 5 minutes before we get started. And a little bit of repetition is actually not bad. So you will learn most of the tools we're talking about today. It's just getting started. Just a little bit slow here. It looks like my laptop hasn't come back from lunch break, so. So when you think of this, right? So what you kind of, see and observe during our tutorial is actually all the different things you need to run an experiment on a Genie slice, and that involves quite a few different things. And so it involves you guys, the experimenters, obviously, right? You wanna run an experiment. It involves having a slice in a Genie testbed, but it also needs some way to run an experiment. Well, first of all, some way to instrument an experiment, then a means to run an experiment, to collect the data from your experiment, right? That's the most important thing, so to speak. You want to observe it and then, log your data and then be able to, analyze your data, maybe write a nice paper later on about it. That means observing that you can plot it live, that you can observe what's going on during the experiment, right? And then finally save it, and then later on, do your analysis of the measurement you've been doing. So what we're trying to do actually with the tools we're building here in our project is to kind of automate what's going on here. But I want you to understand what's a little bit behind the curtain, so you better understand what the functionality is, why you have to do things in a certain way, and maybe also understand what you can do if something goes wrong, right? And so there's a little bit of communication going on, there's different tools, and so I just want to go through this very quickly before we dive into. So if you have a slice, again, just an example slice, that on the left-hand side is your Genie slice, 5-node slice. In this case, we will use only a 2-node slice today for what we want to show. And then we have a persistent server that runs an OML server for the data collection, an aggregate manager, an EC, and an experiment controller, an AMQP server that allows the communication between the measurement points on the nodes and the experiment controller, iRods for archival of our measurements results, and then LabWiki, which is an interface that allows you to define, coordinate, and then run your experiment and actually log information about your experiment. So for a moment, think about you're doing like a 500 node experiment, right? If you do a 500 node experiment, there's no way you can kind of, SSH into every node and start a script or something like this. So you want to automate this. You also don't want to tell that persistent server at what IP addresses or under what host names you can find all these nodes in the experiment, right? And so what's happening is we're using a pub sub mechanism. What's really important here is that for the experiment you will be doing today, and hopefully when you want to use our tools in the future, we have we have images that come with the tools installed already and have post-boot scripts that execute certain processes that then perform some of the functionality I'm describing here. So when you use one of our scripts and bring a slice up with these scripts, a resource controller is automatically started on that script. And what the resource controller does, it has a specification, so it can ping back to that AMQP server and says, hey, I'm up, you can reach me on that IP address. Right? The AMQP server puts that in a database, and now the experiment controller knows how it can reach all these nodes. Right? So that's very nice because it automates that. Think again, 500 nodes or something. They all register with the AMQP server, and then the EC can actually address them based on that information that's flowing back and forth. So he has that information, he can send out information to the resource controllers, which then perform certain tasks. I showed that yesterday, so just to give you one simple idea, you can just specify in your experiment script, you can just specify a system call, right? So you can bring up 500 nodes, and you can do an whatever ls for a certain file, right? And then it will then be automatically executed at each of the 500 nodes. A ping or an iperf might be something a little bit more interesting, or your own application. We will show you today how you can actually, change an application or write a wrapper around your application so it can be started by a resource controller and then also sends measurement information back to OML. Speaking of OML, when you have an experiment running, the measurement libraries, these we call them OMLified applications, collect data and send this data back to the OML server. And if you're happy with the results, you can actually store them in iRods for long-term storage. We just started, so guys, welcome. And then LabWiki is actually the user interface that talks to the OML server and the experiment controller, and we'll learn that a little bit in more detail, how that happens and what happens there when we actually go get started on our experiment. Okay, so that's basically what I wanted just to recap, so you have the moving parts, the communication a little bit, in your head when we go through an experiment, and you understand what's going on. No matter what, feel free to ask questions, right? We've been doing this for several years now, so hopefully we know what we're talking about, but obviously for some of you new material, so if I'm going too fast or if I leave something out, just let me know, no problem. Okay, so what we want to do is actually, since we're a small group, so we had when people signed up, we weren't clear who is actually participating in the tutorial and who is auditing the tutorial. Are you all planning on participating in a tutorial? Right, okay, cool. You don't have a laptop. You don't have to. I just want to make sure if you want to participate, you better get your laptop out now. So I'm not forcing you. Whatever you want to do is fine with me. I just, because else you're going to run a little bit behind and then things could get a little bit tricky. So if you can go, if you open the main page, the GENI page, go to the agenda, click on our tutorial, the entry for our tutorial, you'll actually find a link at the end of that for the instructions. So, you should probably just open that link in your browser. I can actually, show you how you get there. So I'll just say more info here. Go down, we're doing the instrumentation measurement with GIMI. And then all the way down here, you find the instructions. Okay, so leave that open in one of your browser windows because we want to go bigger. Did I click on the right one? Oh yeah, okay. So all of you have a GENI account, right? So that's good. And actually, Some of the stuff we'll just go through one more time because I think, again, as I said, for those folks who are new, a little bit of repetition is a good thing. So you can get going. Let me see what's going on here. Okay. So, I think I don't have to say much more about how to get help. Don't send email to help.genie.net right now. Ask us. You can do this when you try to repeat this tutorial at a later point in time. So, design and setup. Whoop. So what we're going to do today is actually, let me just spend 1 minute on that to give you an idea. Is we're just going to take 2 nodes. So we're just going to take a very small topology because it's not our goal to talk about large-scale experiments today. We did this at the last GEC. What I want to go today is actually, I think Mark Berman a long time ago wrote an application that's a layer 2 ping. It allows you actually to see if your layer 2 connection is up. And that's more and more important, right? Because we're doing VLANs and all this stuff, so layer 2s. And we will show you how you can instrumentize that application to get measurement data from that on VMs on a Genie slice, right? And that, if you have this for 2, you can even do that for 2,000 if you find that many VMs, right? That's an easy piece. I don't know if we have time, we can maybe set up a little larger slice or something like this at some point in time and show you how this works. So it's a small slice, but it's because we want to show you something on the application side that's important. That's why we're not dealing with too many nodes. So we'll deal with the application. I'm sorry, should I stay a little bit more back here to make sure I'm in the video? So if I wander off, just let me know. And then we'll show you how you build a wrapper around the application, and then how you use that to then execute a measurement, obtain your data, visualize your data, and then you can look at the results yourself, right? See if that's what you wanted to obtain, and can do all kind of different things with it. So what's really important is that you have to obtain resources. And let me just go to the Genie portal. I'll just do this as an exercise together. Just give it a moment. Network is a little slow. Are these Ethernet cables live here? Excuse me? Are the Ethernet cables live? Oh, no, it came up. It seems the network is a little slow. So, anyone else having problems? Is that going smooth for you guys? No, it's not slow for me. Sorry. So you want to go into the GEC19 project, right? And create a slice. Okay, and give it a unique name, right? So what I would like to do is maybe we just say gimme tutorial, and I just use Zink for me, and you can maybe just use something for your name or something else, right? Give it a name like this. And with that, we can say create slice. And now we just basically have, the only thing we have done so far is we have reserved the namespace for a slice, right? We have a resourceless slice. There's no resource behind that. And so it's important that we put some meat to it and actually go to the add resources section. And look at the available aspects. And if you, like me, cannot remember names, you can actually, where are my instructions? Oh, here. You can see that we want to look for an aspect that's called GEC19 GIMI. That's the aspect you want to take. So Let me reiterate that because that's an important point here. One of the important things is that you take that aspect because that aspect specifies an instrumentized image that you will boot on the VMs that are part of that aspect, right? So that comes with the tools, with the resource controller, and with the measurement libraries we need here. So GEC19 GIMI, go back here. Here it is, you select that, and then I'll just pause here to make sure everyone's at that step. And the next one is that you have to say where, what aggregate you want to, obtain that slice from, right? And so you can. Are we taking just one rack, or are we taking different racks? Okay. So what we do is I'll just choose Cornell, and then Divya, maybe you can walk through to. No, that's what I wanted to do. So just before you hit here reserve resources, just wait a moment until we want to make sure, because there's other tutorials going on. You're using resources here. We just don't want to make sure that there's an overload on the resources, so we'll distribute that a little bit. No, I don't know what. Can you? You go down from the list. It has to be an InstaGenie rec. So why don't you take the Clemson one? Satyajit is taking the Clemson one. And I'll take a look at you. Have you given Cornell to someone already? No, I'm taking Cornell. Okay, so then maybe you want to talk Georgia Tech InstaGenie. Little further down. Little up, two up. There, excellent. How about you guys? You got yours already? Okay. Do you select the slice? Oh, okay. Good. So if you want us to wait for you, let us know. Okay, good. Everyone else set? You guys set? Good. Okay. Perfect. So now you can actually go ahead and reserve your resources. So we actually have some VMs and a little bit of networking to do stuff to run our experiment. Sorry. Or can I take the Cornell? Yeah. Did I did I hit the wrong one? I thought I had that. Oh, okay. Ooh. So okay. So now hopefully this goes through. I apparently cannot click on the right entry here. So this is gonna take a moment, right? It's going out to the aggregate manager, checking if all the resources are available, get this information, and then it starts bringing your slice up. You're booting an image, right? So that always takes a couple of minutes until you have your VMs up. So yeah. It has to be green. So just wait a second. Yeah. Right. So one of the things you can actually do is we have seen, or cool, at least and that's one important thing, right? It says up here creating sliver. It hasn't created the sliver yet, right? So what you can do now is actually we have this very long logins because that's because of the tutorials here. So we can actually log in SSH into your nodes and help you out if there's any problem. You wouldn't usually see that, but now I can actually launch FLAC, right? I can launch FLAC, and when that launches, you will see that the color coding of flag actually helps you with the status of your slice. It's going to be a moment because it now goes through all the aggregate managers and sees, queries them for my slice. Same in your case, right? And so when it finds the information, it gets back and gives you some update on that in terms of what status your slice is in. So just be patient here. This is just a process that takes time. There's nothing we can speed up about this. And then what you will see is when flag comes up, you really have to just look at the background color. Background color is red, and things went wrong. If it's yellow, it's in the process of bringing things up. And if it's green, we can have a party, yoo-hoo, because things are up and we can start using our slice. So just wait on that for a moment until it's coming up. I'm sorry I'm walking out of your picture all the time. So it's green but not showing anything. So, or is it? No, it's white, huh? Yeah. Yeah, you gotta wait a moment. That's just gonna be a minute or so usually. Well, Peter's is yellow already, so it's booting, right? You know, usually when it's in yellow, as I mentioned before, it's a VM that's been brought up, right? It takes a little bit until that operating system has completely booted, and then you can log into it. Is all your slices? Sure, sure. It's gone lunch break. This is taking a while, huh? Any luck for you guys? Which rack did you choose? Oh. I don't know. It could be just a network, you know. Things a little slow. Oh yeah, actually mine is now. Yeah, sorry, I apologize, but this is just slow today. Sure. You want to do that? Oh, you want to have people do that? Well, mine just came up. So what? But we do a break and then go in. So again, now you see it's yellow, right? Not good news. So I mean, not terrible news, but also not good news. We cannot log in at this point in time. So what we'll do in the meantime, right, to keep you guys busy while we're waiting on this, is we'll actually go back to the portal. And for other folks who have not created an iRods account so far, so let's just go through that quickly. It's going to take 2 minutes. So if you go into Profile, right, go under Profile on the portal, let your flag open. It'll, you know, work on the background. Go to, where did I put this? You know, I have an account and I haven't used that in a long time. Oh, it was up here for a while, right? They moved that under here. They just do that to confuse me. And then you go here and create an iRods account, right? That's one important thing is that still the warning, right? You get a warning that you have to write down that password you're getting, right? So, you know, you all have pens and paper on your table. No excuses, right? Write down that piece of information. You don't have an iRods account? I know, I was hoping. Gotta go, yeah, go back to the portal, go to Profile. Yeah, that's fine. But go to create your iRods account, just go to Profile and create your account there. Profile. And then go to Tools. and say create iRods account. Okay. And now write down your password. Okay? Good. So we need that later on. And so that was a good idea, Divya, just to bridge that for a moment, right? So we're waiting on this to come up. Let me go back to the instructions. Again, this just can run in the background. It shouldn't worry you. We've gone through this. And as you know, we cannot do the login so far because we don't have these guys up yet. But that's the next step we would like to get to. So it's probably that everyone is bringing up you know, slices right now. Also, I think we have 2 tutorials in parallel to ours. So you know, it's just a lot going on at the moment. Okay, so what I'll do is, you know, you just leave that running and pay a little bit attention to me in the meantime. We'll come back to this and to our notes. There's nothing for you to do at the moment. I would just like you to, you know, follow me for this couple of minutes. If one of you, why don't you leave Flag open? Just glance at it with one eye. When one of your flags turns green, let me know. But I would like to talk about LabWiki for a moment and see how that helps you to, you know, orchestrate and execute your experiments. So what you see here is actually that LabWiki tool, which is, you know, you access it via your browser. And it is, you know, it sits on our persistent server, as I just shown you before, and talks to the experiment controller, right? And what you do is to orchestrate an experiment. We use, in our case, we use an experiment language. I apologize, just have something else on there. If you go to the where's the experiment file? Oh, shoot. I'll just give you an example. Sorry, my mistake. So I'll show you. So this is the experiment language. Don't worry, we'll go over this in a moment, so you can define your experiment. Here you define certain properties to certain nodes, and then you can actually, you know, if you have written your experiment script, you can actually run that experiment script by pulling that over. It fills out a mask for you, and you can run this, right? I cannot run this experiment right now because I don't have the underlying slice for this experiment up, right? You know, your experiment is always, or in many cases, tailored to the slice, to the resources you're using. One nice thing with LabWiki is that it actually allows you to document your experiment on this wiki page here. And so what we have done is actually, when we use that, as soon as your slices are up, we actually put the instructions for the tutorial on here, right? So you don't have to jump back and forth between the browser and LabWiki. So that's kind of a good thing. It makes it a little bit easier. So let's see. Oh, this is still yellow. Jeannie, have you been in a different tutorial? How are the slices coming up there? It's taking long here. Oh, thank you for coming into the room. So that's just so. Anyone else? Okay. So we'll just wait a short moment, a couple more minutes. That'll be fine. Yeah, I don't know if this is the network or what's going on. It's a little on the slow side. Well, you got a green one, huh? Excellent. See, they should be ready pretty soon. You know, you want to. Yeah. So while this is coming up, why don't you bring up LabWiki? So what I would like you to do is actually, um, you can actually go to on the instruction page, go to run experiment. Oh no, sorry. Oh, it's at the bottom. Should be at the top. That's okay. So if you go all the way to the bottom, if you're not good, if you don't go all the way to the bottom, um, it's too much stuff on you. 3. Well, what I have to let you know is actually where to point your browser at, right? So sorry, that's what I thought I was there. So point your browser to me9.casa.umass.edu, that port 4000. You got green. Is yours green now? Good. Okay, and then you just have to log in. There's a green button you want to push when you're there. Log in. And then what I'd like you to do is actually, since you don't see that script here right now, where do you have the original, Divya? Okay, so what I want you to do is actually go, sorry, kind of when you have this way. No. Down here. So just copy everything out of here, right? Take all that. And if my browser would work, I could actually go down further down here. But just copy the whole screenshot here, right? And then when you're done copying that, go over to LabWiki again. And then what you can do here, when you are in the prepare pane, you have this button here, right? This little wheel. And that allows you to create, a new one. It's really important that you say wiki here. Then you can give it a file name. Say maybe ping, layer 2 ping layer 2, OML ping, whatever. What? Yeah. Huh? Okay. Oh yeah, sorry. I thought, doesn't it say that? I thought it says that. Sorry if I went over that. Okay. So then, you can create that. You can just paste it in here. And when you paste it in here, you can hit the save button, right? And when you're done hitting the save button, let me just pull mine over here. You can actually, after you have saved it, pull it over here, and then you have your instructions over there. You have any questions? So, yeah? Oh, no. Oops. Yeah, oh yeah. You should use Chrome, actually. Sometimes there's small issues with Firefox. Everything okay? Good. Oh, you got green? You have a question? Yeah, sure. Yes. Name? No, just use something like maybe layer 2 ping or something like this. And then make sure it says wiki and yeah, exactly. Now you can paste. Yeah, say no, I think you have to say create first, and then you can paste things in. You click on that. Yeah. Oh yeah. Yeah. Now you can in the middle. Yes. The middle pane is where you do all the editing, right? And I'll show you in a moment that you can either edit experiment scripts or wiki documents, right? And the wiki documents in this case are written in Markdown. Right? It's just what's been used for the description language here. Cool. Just hit the save button. And now you can actually pull it over. Just drag on that icon, and then you have your instructions there. Good job. Yes. The whole thing, yes. So that we're just doing this to show you, to give you an idea how you can start your own wiki, right? You want to write your own experiment, or you're working on your own experiment, and you want to get your own instructions in there. So this is already preset from our side, but that's how you would start a new document. Right? Again, just ping us. There's a lot of people in the room who can help if you run into any problem. Just to copy it out of the instructions. The layer, just the markdown file. Wait. It's right under the screenshot under 3.2.1. Oh, that's not good. We get there, don't worry. Now you can go back, open that again. Just pull it over here, grab the icon, pull it over. Now you have your wiki here and you can read the instructions. Cool. Excellent. What's happening? Oh. Yeah, there's I don't know what. Yeah. Your sender's green. It's hopefully going to be there any moment. Did you have yours is up? So, I'm sorry. Just turned green. So, be a little bit patient. I'm sorry. But again, other tutorials going on. There's a lot of people bringing resources up right now. If you do this 6 o'clock Monday morning, it should go fast. It's tomorrow morning, yeah. Sure. You're not from Cornell. Where are you from? Drexel. Okay. I have a good friend out there, actually. What did you say, Ishwa? It came in 2 minutes? I don't know what it is. We'll just wait a moment. I'll just wait a couple more minutes and then get going. So since mine is up, I just want to show you something while we're waiting here. And just SSH in one of the nodes. This must be the network. Oh, wasn't. It's just that the screen popped up here. Oh yeah, you know the problem is when you have a split screen, it's popping up here. So the one thing I want to show you. This is great. This is again the issue with the. Yes. You can try it any other way. Yeah, give me a second. I just need to copy that. I'll just do this quickly here. What was the port? Oh, actually, you can look it up. Sorry. 37947. No, that's actually not the issue. Yeah.
You have to do to get to your home directory. You have to do a delay.
No, that should be. I'm right here. Right.
Oh, okay. Just try the delay because I did that and that worked.
Nope. That's great.
Do the port after. That's what the issue. You have to have the port after the thing.
This is the first for me here, so give me 1 second. Correct. 37947. Ah, this is perfect. You want to log in there? Well, why don't you try it here?
Just try pblum. Is that your TM here?
It doesn't matter, you just have to type in a password.
Nikki looked at it and I owned yours and you owned mine.
So for those who have a green flag, can you just do me a favor and open your an SSH into the nodes? Something is really weird here. I have not had that. It's a key issue, right? With. Oh, okay. what did I do? Something with my name in GIMI tutorial Zink. Did you try your SSH in? Oh, yours is still yellow. God. Yours is green, right? No, yours is green, right? And your SSH is working? Let's give it a second. We might not even get to show you our tools because other tools are not working. What? Yeah, no, I don't think that's. You should at least have a. You tried that before? Just close it and try it again to SSH in. Uh-huh. Oh, you have two SSHs up, right? You can log in? Good. Did you try this in any of the tutorials earlier? Okay. I don't know if there's an issue with your SSH. Yeah, why don't you take? Why don't you take yours up? Oh, Divya's gonna just. We're just gonna switch laptops so we can move on. Jeannie, can you just have the 3 folks who don't get slices take their slices down and set up new slices? I don't really know what's going on there. Oh, this is mine right here. Okay. Yeah. Take it easy. I just want to go into the Nuka tools and show how we. Oh, this is not Nuka tools. Sorry. Where do we see the resource controller? Just the root logs. Well, it's not ls. So actually, the only thing I wanted to show you if I had an SSH right away is actually now, if you can log into that into one of the VMs of your slice, you can actually look under var log, OMF or RC log, and that is actually what I described you before with the AMQP. There's a process we start automatically because we're using an image that has our tools already on there that now automatically connects to that server. As you can see, there's a connection using. Do you have a pointer up here by any chance? No, this is not a laser pointer, right? Oh, wait, I'm stupid. I got one myself. So if you look here, right, so here you see actually the communication, how it connects to the AMQP server, right? So that's why I'm saying, use one of our images, because that's automatically happening then when you use one of our images, okay? Just one of the things, and then there's other stuff installed here. Divya, do you want to drive from here on, since this is your laptop? So I think we should go into the application part now. Jeannie's just gone, I think, to get some help from, I don't know, either the InstaGenie folks or the Flag folks. Yes. What? It's green? Hey, patience, huh? I know we're all not patient. I'm sorry. This is like we haven't had this in. Yeah, I know. I'm with you. Hopefully you can log in. So you still cannot log in? Can you? Do you have a putty or something? This is a no. This is a Linux you're running on this box, right? Just open a shell and do an SSH to that. Yeah. Yeah. Go back. Oh yeah. Yes. Exactly. Absolutely. That's right. Oh, he can log in. You're green. You're green. You're green. I'm sorry. What? It's not. It's still stupid because you cannot go on with the tutorial if this thing still don't come
There
up.
might
You know.
not be resources for him to get.
Well, yeah. I think you should just try to get a new one.
Yeah,
Go back.
I tried with the different platforms.
Okay. Okay. So then wait a moment. Yes. How are you doing? Yours is up. Okay. Excellent. So Divya, why don't we? And we'll catch up with you and make sure you don't get lost. And you know some of that stuff already. So. This we have like this.
Has everyone SSH into their notes? Okay. Um, just gonna copy this. Should work. If you could just copy this and then run it on both the nodes that you have. Yeah, just before the CD. Yeah, just these 3 lines and execute it on both nodes. Sorry? The ping plus. We are downloading the ping plus and then we just build the binaries there. Can you run this on both nodes? And then we do the same thing here. Is everyone at this step? Sure. Should I bring up the instructions? Does anyone want to see them? Okay. Is everyone here? Okay, so we can move on. So, and then what we do is we just go into the folder and make it. Oh, everyone's done with this? Okay. Just slow. Okay. And then what we are actually running is the Ping Plus that most people who were in the Intro to Genie tutorial would be familiar with. We are doing the exact same steps there. We are going to run it manually and then we look at the output and pass it. So we just go here and run these steps. On the receiver node, we just copy and paste these instructions and run them there. So So here what we do is just try to ping both the nodes and see if our connection is up. So you can see that, oh great. So the IP addresses are not up. For some reason the interfaces don't seem to be up here. What we can do is we can just bring them up and ping, or we could just go ahead and try doing the layer 2 ping since we don't have the IP interfaces. I'm just going to skip over that part and we can just try it directly with our layer 2. So this is probably one of the reasons why we can use the layer 2 ping is when you don't have the interfaces up. So on the receiver side, we start the server. And when you start the server, just before you start the server, you can do an if config and copy over the MAC address because that's what you're going to use to communicate between them. And that's ETH1. Yeah, sorry. So this interface, I'm going to start it up on 10002. You could do the same. And now my server is listening. So I go here and then copy over this last line here. And just replace the MAC address with whatever MAC address you have. So this is the MAC address of your receiver. So we can see that the layer 2 connection is there, though we don't see the IP interfaces. You can see here that we actually have a round trip time that we get. So, and the final argument change you can specify as a count, for example, and then it will run 6 pings. So is everyone here? Can everyone see this output? Okay. Now in LabWiki we have an application called Ping OML2, which actually takes care of the layer 3 ping. So here what we are going to do today is parse this output and make a layer 2 instrumentized ping. Here on your screen what you can see is the OML parser bit. What you use here is the regex parser, and all the outputs that you see here, you can just map them one to one, and parse them according to the regex parser syntax, which you can find anywhere online if you have your own applications. But for this application, it's already been done. So we have the RQ, RL, and RTT. I guess here what we really want to observe is the RTT. We parse the entire output. So the first step is to parse the output. And if you have any questions about this, please let us know, because if you don't understand this, then it's difficult to know how the regex parser works and how you can instrumentize your own application. Actually, towards the end of this tutorial, there are a couple of links which have examples that include parsers. For example, if you have very simple outputs with just spaces in between them, you can use the parser that's already there. But in this case, we want to write our own parser because our output looks like this. So this is not something that the OML for our gem would parse. But yeah. So I'm just getting to that in just a minute. This is just an extract from the full code, which is here. And to do this, what we will do is go back to our nodes here. And today, we are not going to instrumentize the server. You could try that too. But what we are going to instrumentize is the client. So first, we create a file. So I usually run applications from this directory, and that's why I'm just creating it here. But you can, as long as you remember the path, because when you try to run your application from LabWiki, you need to provide this path. So since this is a node that I've already reserved, I have the script on here. If you go to the same place, you will not be able to find anything there. So you need to copy and paste this full code here. Till the very end into that file there. So is everyone at this point? So I'll just go over the script a little bit. So I've created here a Ruby file because I'm using the Ruby gems and I'm using the UML for R to do the parsing. It's okay. I can go back to this one and explain it from. Okay, so we had 3 lines and I've defined a measurement class for each line. So what we do is we specify the parameters that go into each line. This is just easier to do the parsing. So we have for RQ, RL, and RTT, and those are the 3 measurement points that are defined here. And if you go back to the sample output that you just got, you can see that, again, it's just a one-to-one mapping, and you just need to specify that particular measurement point and the data type here. So for the RTT, we have just one parameter here. So we say measurement point RTT, and then we save the RTT to a particular location in the script. And after this happens, we need to look at this class right here, which is the wrapper for this application. And here what we do is, on LabWiki, you need to specify certain parameters. When you run the experiment manually, what we did was we specified these 3 parameters. That's the MAC address, the interface, and the interface number and the interface name. So these 3 are variable parameters. So whenever we write an application, we want variable parameters to be selected by the people who are writing the application. So we want to give them the choice to select whatever they want. They don't have to go back into the application and change it every time. So we write a wrapper for it. And that's what the arc parser does. So when you say arc parser here, you can define whatever parameters are variable for your code. So in this case, it would be the destination hardware address, the interface number, and the interface type. And this was the parser that we just saw. It's actually looks a little complicated, but it's a very simple regex parser, and it works very well. And here, when we hit start, it's going to call this from the, it's a system call. So when we hit start, it goes here to this particular line and runs that exact command that you just ran on your terminal. So it runs it on your node, and here the path that we've specified is bin ping plus. You can put this path anywhere. Since I have mine in bin, I say bin ping plus. In a minute, we'll just copy this over to the bin folder. And after that, you need to say this, since address defines the MAC address of the server. So this is a variable parameter. Ethernet type and Ethernet number is a variable parameter. The count is also a variable parameter. So this is the exact command line command that you have to specify at this point in the script. And then, of course, you have the start and stop, because we do a control C and kill the application, or these things do similar things from point of view of LabWiki. So this probably wouldn't change too much for any application that you write. It would remain almost the same. Any questions? Now I'm just going to clear the screen. So one thing is we need to change the permissions of the application file that we just created. So this is what we do. And again, LabWiki has to go into this script and then run the ping plus application. So we need to change the permissions of that too. So we change the permissions of the ping plus, and then we just copy over the ping plus to the bin. Is everyone here at this point? Now, since we already copied over the markdown script, the next step is to write the application. So we can now use LabWiki to run that application that you just put on the node. So if you scroll down to 3.2.2, there's a sample script there. So we didn't put this into LabWiki beforehand, so you'll have to copy and paste this over there. And this was so that the script would sort of make sense to everyone here. So the application that we just saw, we said we had an arg parser for the 3 variable arguments. And when we're running the application from LabWiki, the same arguments are what we define as properties. So there's a def property function which allows you to specify what the MAC address is here. And this would all change based on what you define in your application, which is on your node right now. So you could have anything, like if we have a few minutes towards the end, I could just give you a peek into the OF, the OpenFlow parser that we wrote for the OpenFlow statistics. And here we say we want to run this application on one node. So we define the node as a group. And again, a group can consist of more than one node too. But in this case, we have a 2-node ping. So we say property source 1. But if you have one server and you have multiple clients, you can run this same application on the 3 clients too. So you can say property.source1 and then comma property.source2, and that's how you can specify a group of resources. And here we define the target as a variable property. Why it's a good idea to sort of not set this in the script and set it as a property. So let's go to LabWiki. When you click on since we're going to start writing this LabWiki, we're going to run our experiment in LabWiki. I'm just going to leave the plan window out of the picture for a few minutes. Oh, yes, sure. So you can again click on the little wheel on top and say my layer 2 ping. You can name it whatever you want, but the only issue here is that you have to select OEDL if you want to create an application script, and you have to select wiki if you want to create a markdown script. And then you say create. So since I already have it here, it's just showing up for me. But if you get a blank screen, which you will, you need to copy and paste this script here. Into LabWiki. And then click on save. Was everyone able to save their experiments? Okay. So we just saw that here we define what our node properties are, and then we say we want to run this ping 30 times, and then we say the interface number is 10002 because that's what we're running our server on. And then here the Ethernet interface is also defined as a separate property. And this is the on event all up and install is going to wait until all your nodes are up and all your applications have been installed before it actually runs whatever you want to run on these nodes. question. So here you can see it says all groups.start applications. This is because we just have one group here, and that's source 1. But here you can also specify the name of the group that you want to run your experiment in. So I would have to say something like this and say source 1 and dot start application. So this is going to load all the applications which I've defined in my source 1 and start that up. And after 70, so what this does is this is actually an absolute time. So when your experiment starts, it's at time 0. So when you say after 70, you're starting up your applications after 5. So your application is going to run for 70 minus 5, 65 seconds. And then you have to say experiment done so that your experiment is finished. So this would run the layer 2 ping for us, but what we still need to do is to define what we want to see in the graph, because we can see any measurement that we define, we can see that in the graph, we can see that in a plot. So here in this specific OEDL script, we've defined 2 graphs. One is a line graph which shows you the RTT, and here you just specify the measurement point that you actually defined in the OML script that we just wrote. So that's ping RTT, and if you go here, you would be able to see that that's what we've defined this as. So this is the name that we gave to our measurement point, and that's exactly what we need to use here while seeing the graph. And here we define 2 graphs. One is the line and one is a histogram. And you can use many other graphs, and at the end of the tutorial there's a link where you can see what kind of graphs you want to see and things like that. So just before we actually execute our experiment, you need to make sure that the server is still running, because we haven't instrumentalized the server yet, so we need to manually run the server, and my server is still running here. So if that's done, you can go back to LabWiki, click and drag this over to the right, and you should be able to see a window like this. And then we select the project that we want to run the experiment in. Here I already have a context, so it's showing me this as a context, but you need to click on add experiment context here, select the project that you want to run your experiment in, and then give it a name. So I'm just going to create a new context here, and that will show up here. Okay. Is everyone here? So when you actually click and drag this over, you should be able to see that the source 1 and the properties that you define are actually specified here. You can actually specify them on the right. Since I don't see them, I'm just going to redo this. Now I see them. So if you're at this point, then there's no syntax errors in your script. If you click and drag over and you don't see the properties or the script doesn't show up, then there might be some syntax errors which need to be fixed in the script. So we can go here and select the slice name that we want to run this experiment in. Since I'm using slice, which is not in this project, I'm going to select my slice from here. And this MAC address should be the MAC address of your server which is running. And then I can just copy and paste it over there. But if you don't define this as a property, as you can see here, what from the script, only the properties that I've defined show up on the right. So I can't replace them there. I have to go all the way to the script and replace it here. So here I haven't defined the count and IF number as properties, so I have to replace it there, save it again, and click and drag over. So what would be so much easier and more convenient is to just define it as a property, so that when we do repeated runs of this measurement, we don't have to go back and change it in the script. So we give our experiment a name. And this can be any name that you want. And then we run our experiment. Since we have a lot of people running this experiment together, it might be the case that we see this experiment as pending for some time. So LabWiki on the back end uses a job scheduler, and what LabWiki does is schedules the experiments in the order that they've been submitted. So when my status says pending, it means my experiment is not scheduled to run yet. So the status should go from pending to running to either finished or failed. So failed is again red, and we don't want to see that. We want to see our experiment finish. So first we start, okay, my status has changed to running. So that's a good thing. Can everyone see graphs? Okay. So the first graph that you can see here is the round trip time. And the second one we see here is the histogram, which is what we defined in our script here. So, to define this graph, it's a very simple SQL query that you need to execute using LabWiki syntax. So it's just like doing a SQL query, and you specify what you want to see on the x-axis and the y-axis. What's also really cool is that we can click and drag over this graph from here to the plan window. So it's easy for us to see both our graphs. So I'm going to click and drag the line graph here, and then I can bring up the histogram here and the line graph here and see what my results look like. Just another quick thing about the graph syntax is that when you scroll down to your graphs, you can see actually just one color here, but in the plenary demo we had 3 colors because we were actually getting the OpenFlow statistics measurements from 3 parts. So how we choose what we see or what we group by is by again defining it here in the script. So now in this script we've defined this to group by the destination hardware address. So that's why it's going to show us one color for every hardware address pinging the server. And in this case, we only have one client, but if you had multiple clients, you could see them all in different colors. And in fact, if you just zoom in on a point in your graph, you should be able to see the particular hardware address and the value at that point. There's a bunch pending. Okay. So let me just show this. So if you go here and type the name of your experiment, sorry, not here. So if you type the name of your experiment here, it should come up in a few minutes. Hopefully. So I can see from the logs that some people might have some syntax errors in the script, so I'm just going to come around and see what's going on. Do you want to try another port? Because we have it running on multiple ports. You can try to use 4609 there. Yeah. It might be faster. 4609. Yeah. Yeah, sorry, it's a little slow because of just your scripts should be there. It's just a different instance. Did you try to type? You can type in the name of your experiment. So let's say CV. Can you try to switch over to 4609? Severe, no. That should come up a little quicker because everyone's using 4000 right now. It's very slow, yeah. I'm switching people to other instances, so. Let me check. Yeah, I redirected a couple of people to 4609. So on the same tutorial page, if you go to the execute, sorry, this is the wrong tutorial. Okay, this is the right page, but I forgot to change the title on this, sorry. So if you click on this link here, this is the gem that you actually use to parse all your output in LabWiki and create OML applications. So when you click here, you can see that there are several examples, and I actually used this particular example to make the OpenFlow statistics parser. And if you scroll down here, you can see that it's very similar to what we just wrote. It's even simpler, and where they're actually doing the parsing is right here. So they have very simple output in this case, where they just have outputs, different parameters separated by spaces, and what they're doing is they're just reading that into, they're just passing it, and based on that they define measurement points here. So this is what we use to do the OpenFlow statistics measurement. And this OpenFlow statistics measurements, what we actually did was we collected the measurements from the place where we were running the controller, and after that